Hello everyone, welcome back to Math with Allison. Today we're working in our sequences and series, so we're going to be talking about how we can integrate and differentiate different power series. So let's go ahead and dive into it. We're going to begin with a very generic one, so f of x is equal to 1 over 1 minus x. We can represent this function as a power series. It's actually a geometric series, right? So 1 plus x squared plus x cubed, yada, yada, yada. So remember, this is, like I said, a geometric series. So this also has to be for x values less than 1, right? So how do we differentiate or integrate a power series? That doesn't, it's a little bit weird. Let's go ahead and begin with a function. So here we have our function f of x is equal to, and I'm going to rewrite this as 1 minus x to the power of negative 1. So that way I can take the derivative. You could also use quotient rule. I like writing it with a exponent, so that way I can use power rule. But this becomes negative 1 times 1 minus x to the negative 2 times the derivative of the inside, so it's going to be negative 1. So rewriting this, those negatives cancel out, and you're just left with 1 over 1 minus x squared. So we know how to differentiate functions. That's not as exciting. What we want to do is represent now this with a power series. So one way you could do that is you could just differentiate the power series. So f of x is also equal to 1 plus x squared plus x cubed plus all the way down, right? That's how I can write out the power series. So I can take the derivative of that. That's going to be 1 plus 2x plus 3x squared plus so on and so forth. Now, if you wanted to, you could rewrite this as the power series, right? So we have n equals, and I'm not going to write our starting index yet. We're going to look for the powers, right? So we have a coefficient of 2 and an exponent of 1. For the next term, we have a coefficient of 3 and an exponent of 2. So what we have is a larger coefficient than the exponent. We're just adding 1 to the coefficient, right? So now we can see what our starting index should be. I think, yep, we can go ahead and start at 0, right? If we plug that in, we get 1x to the 0, which is just 1. So what do we have? We have 1 over 1 minus x squared is equal to the summation n equals 0 to infinity of n plus 1 times x to the n. That is one way you can differentiate a power series, is you can just write out all the terms, take the derivative, and rewrite it as a power series. Another way is you can learn how to differentiate an actual summation. So here we want to take the derivative of, and this is going to be the summation, n equals 0 to infinity of x to the power of n. We are taking the derivative of x. So let's look at our x term. We have x to the power of n. I know how to take the derivative of x to the power of n. N, in this case, is not necessarily a variable. You just have to think of it as a number, right? It's the exponent. So we're going to use power rule. So I'm not taking the derivative again. This is equal to the summation, n equals 0 to infinity. We bring that power down, right? So we have n times x to the n minus 1. This is where we have to also be careful with the index, because notice I can't start with 0. If I plug that in, I get 0 times x to the 0 minus 1, which is just equal to 0. But our starting value is not equal to 0. Our starting value is equal to 1. So I need to increase the index by 1. If I start at 1, then I get 1 times x to the 1 minus 1. That is indeed equal to 1. So when you're differentiating, you can totally take the derivative like you know how to do. You just have to be careful with the index. So notice that these two power series are actually the complete same, right? If I were to increase my index in this one, right, let's go ahead and say we have the summation and we're going to increase it to 1. That becomes n, right, to the x, n minus 1. When I add 1 to the index, I subtract 1 from the series. So here we end up with the exact same things. It's just two different ways to represent it. So that's how you can differentiate. You can either differentiate the actual terms of the power series, or you can differentiate the power series itself. So now let's go ahead and think about integrating. Same thing, let's go ahead and just take our function, right? So f of x, in this case, f of x is equal to 1 over 1 minus x. Let's go ahead and integrate. So capital F of x, right, that's going to be the integral 1 over 1 minus x dx. So we know this is equal to negative natural log of 1 minus x plus some constant c, right? So again, functions, that's not the interesting part. We know how to do that. we want to learn how we can integrate the power series. So you could do the exact same thing. We also know that f of x is equal to 1 plus x squared plus x cubed, so on and so forth. So let's actually just integrate the series. We get 1 plus x squared plus x cubed plus blah, blah, blah in terms of x. So if we were to integrate, we would get x plus, that's going to be x squared over 2 plus x cubed over 3 plus x to the power of 4 divided by 4 plus so on. But you also need to add on your constant of integration. So what we have right now is a power series, and we need to find a way to represent it. So we have the summation, n equals something to infinity. Let's wait for our index until after we write it out. So here we get x to the power of n, and we divide by that same power, right? X squared divided by 2, x cubed divided by 3. Now, what do we start off with? We start off with x. So our starting index is going to be 1. So what we have right now is that the negative natural log of 1 minus x is equal to the summation n equals 1 to infinity of x to the n divided by n. Now, you're probably wondering what happened to the c right here. We do need to be a little careful with the c. So here we have plus c. Let's just say that. If we were to plug in x is equal to 0, we get negative natural log of 1 is equal to, if I plug in 0 for x, that whole summation is going to be 0, right? We get 0 plus 0 squared over 2 plus 0 squared over 3. This is just going to be equal to c. And what's natural log of 1? Natural log of 1 is equal to 0. So in this case, we're going to choose c to be 0. So I'm going to erase this plus c, and I'm going to say when c is equal to 0. Now, what I want to do is I want to get our function all by itself. So I'm just going to multiply that negative value over. So we have the natural log of 1 minus x is equal to negative, and we get the summation n equals 1 to infinity, x to the n divided by n when c is equal to 0. Now we should also be careful with our x values because remember, we're working with this function where we have the absolute value of x is less than 1. That has to be true even when we integrate it. So we also have this is going to be when absolute value of x is less than 1. Same thing for when we're differentiating, right? This is going to be when the absolute value of x is less than 1 because that's what we're starting with, right? We're starting with the geometric series. Now thinking about integrating again, you can integrate the individual terms like we just did, or you could practice integrating the actual series. Integral of the summation n equals 0 to infinity of x to the power of n dx. So let's go ahead and integrate this. Remember, we're just integrating the x. So go ahead and treat n just like you would a number. So summation n equals something to infinity. We'll do the index last. And now let's integrate. We add 1 to the exponent, and we divide by that new exponent. And remember our starting term. Our starting term is going to be x. So how can I get x? That's when n is going to be equal to 0. And actually, these two are going to be exactly the same. Just notice one is indexed at 1, one is indexed at 0, right? So you can practice integrating the actual terms, which is a bit safer. You might have less errors with that. Or you can practice integrating a series, right? Whatever your heart desires, whichever you're more comfortable with. Integrating the actual terms just might be a bit safer. So let's go ahead and try some examples. We want to find the power series for inverse tangent of x. And there's a trick here. The trick is that inverse tangent of x plus some constant c is equal to the integral of 1 over 1 plus x squared dx. We're going to go ahead and use this fact because 1 over 1 plus x squared is very close to our geometric series. So we have 1 over 1 minus x is equal to, and I'm going to write out all the individual terms. So this is equal to 1 plus x squared plus x cubed plus blah, blah, blah. So 1 over 1 plus x squared, I'm going to rewrite it so that way it looks like this series. So 1 minus negative x squared is equal to, now I can plug in what I know. So here x is all of these terms, and I'm just going to go ahead and replace all my x's with negative x squared, right? So 1 plus negative x squared plus negative x squared plus negative x squared cubed plus blah, blah, blah. This is equal to 1 minus x squared plus x to the power of 4 minus x to the power 6 plus blah, blah, blah. So let's go ahead and integrate this. Let's go ahead and just plug it in. So the integral of, and that's going to be 1 over 1 plus x squared dx is equal to integral of 1 minus x squared plus x to the fourth minus x to the sixth plus blah, blah, blah dx. So when we take the antiderivative, we get x minus x cubed divided by 3. That's going to be plus x to the power 5 divided by 5 minus x to the 7 divided by 7 plus blah, blah, blah. So we can go ahead and try to write this as a series. We get the summation n equals something to infinity. Make sure to do that at the end. And here, notice we're working with only odd powers. So this is going to be x to the power of 2n plus 1. And we're going to divide by that same exponent each time, right? X cubed divided by 3, x5 divided by 5. One thing that we're missing is the alternating negative sign. So here we're going to have, and it's going to be negative 1 to the n. Negative 1 to the n times that whole thing. So let's figure out where we need to start. So I want to start at x. So if I were to plug in n equal to 0, I get negative 1 to the 0. That's going to make it positive. And that's going to be x to the 1 divided by 1, right? So that's going to be our x term. So here, this is what we have. Inverse tangent of x plus c is equal to that series. Now, we want to find what the c value is equal to. So let's go ahead and try plugging in an x value. If we were to plug in x equals 0, we get inverse tangent of 0 plus c is equal to, and now I'm going to plug in 0 for all of those x values. You just end up with 0. So what is inverse tangent of 0? 0. This tells us that c has to be equal to 0. So what is our actual solution? So that tells us that inverse tangent of x plus 0, so I'm not going to even write that, is equal to our summation. Now remember, this is a geometric series, so we also want to make sure that our common ratio is going to be less than 1. So in our case, we have that negative x squared has to be less than 1, which is the exact same thing that the absolute value of x has to be less than 1, right? So this is going to be true for all x values between negative 1 and positive 1. And that's how we can represent our function with the power series, right? And we used an integration technique. Let's try one more. Here we want to find the power series 4. So let's go ahead and rewrite this. We know if we have division, it's actually going to be subtraction with natural logs, right? So that's going to be natural log of 1 minus x. And actually, we already found natural log of 1 minus x. Let's scroll back up. We have it right here. The natural log of 1 minus x is equal to this whole thing. So let's go ahead and rewrite that. So if we were to write this out, right, we get negative x minus x squared over 2 minus x cubed over 3 minus x to the power of 4 divided by 4 minus blah, blah, blah. Okay, so now we have the natural log of 1 minus x. We want to find the natural log of 1 plus x. So let's go ahead and manipulate it a little bit. I can rewrite this as the natural log of 1 minus negative x. Now we can plug in negative x into our power series, right? So we get negative summation n equals 1 to infinity, and that's going to be negative x to the power of n divided by n. So let's go ahead and write out all the individual terms, right? So our first term is actually going to be x, and it's going to be minus x squared over 2 plus x cubed over 3 minus x to the power of 4 divided by 4 plus blah, blah, blah. So now that we have both parts of this function, we can go ahead and combine it. So we have the natural log of 1 plus x minus the natural log of 1 minus x is equal to, let's go ahead and plug in our terms. So 1 plus x is going to be x minus x squared over 2 plus x cubed over 3 minus x to the power of 4 divided by 4 plus blah, blah, blah. And now we're going to subtract all of the natural log of 1 minus x. So that's going to be negative x minus x squared over 2 minus x cubed over 3 minus x to the 4 over 4 minus blah, blah, blah. The first thing we can do is distribute that negative sign. So all of those are going to become positive. Now we can see if anything cancels out. So we have minus x squared over 2 plus x squared over 2, minus x to the power of 4 plus x to the power of 4. All of the even ones are going to cancel out, and we're going to be left with double of all the odd ones, right? So 2x plus, and that's going to be 2 times x cubed over 3 plus all of the odd terms. So if we wanted, we could pull out that 2 and we're left with x plus x cubed over 3 plus blah, blah, blah. And we can write this as a power series, right? We have the summation. This is going to be n equals something to infinity. We have that 2 on the outside, and now we have odd terms. So we have x to the 2n plus 1 divided by 2n plus 1. Now we're starting off with 2x, so our starting index is going to be 0, right? We get x to the power of 1 divided by 1. So we found our power series that represents it, right? And this was going to be when c was equal to 0, right? Because that was our integration factor. And it's also going to be our common ratio when absolute value of x is less than 1. So that's all I have for us today. If you enjoyed this video, I have many more like it, so make sure to check out my playlist. They're linked down below. Otherwise, please give this video a thumbs up and comment other topics you'd like to see done. Thanks for watching.